More to a good soldering tip than meets the eye. First, there is the copper core. Then a plating of iron. Next, a plate of nickel. And finally, a plate of chromium. The solid copper core conducts the heat from the reservoir to the work and is the heart of the tip. The iron plate provides a harder wearing surface, giving the tip a longer life. The nickel plate protects the tip from the corrosive action of the soldering process. The chromium plate makes the metals of the tip immune to the action of the solder. Because of the reactions of air and flux upon the surface of hot metal, oxides form on the tip as it idles and cools. For reliable solder joints, these oxides must be removed. Therefore, the first step in good tip care begins before the soldering starts, while the iron is cold. While the iron is at room temperature, a wire brush can be used to gently remove the scaly oxides from the tinned area of the tip. An abrasive polyurethane foam stick or a 100 grit emery cloth can also be used to effectively remove the oxide. Care must be taken not to damage the protective plating of the tip. The next step is important, whether the tip is new or newly cleaned, and that step is tinning. Applying a protective layer of solder to the exposed metal of the tip. With the iron at room temperature, wrap rosin core solder around the tip and clip the ends. Plug in the iron. Wait for the solder to melt. Wipe off the excess solder and the iron is ready for immediate use. The first step in the actual soldering cycle is wipe the tip on a clean, damp sponge. This is necessary because as the iron idles in the holder, the hot metal of the tip interacts with air and solder to create the troublesome oxides. Make the solder joint. Heat the work with the tip. Melt the solder on the side of the work away from the tip. Re-tin the tip. Just a touch of solder to protect the metal of the tip. Return the iron to the holder. Do not wipe the tip on the sponge before placing the iron back in the holder after completing a solder joint. And keep foreign materials such as epoxies, cements, and coatings from getting on the tip and burning. They foul the tip too. Remember this cycle. Wipe the tip, solder the joint, re-tin the tip, return the iron to the holder. Today's soldering tip is a unique tool designed for specific tasks and requiring special procedures and care. Following the basic procedures of good tip care outlined here will prolong the life of the tip, reduce the amount of solder used, and result in more reliable solder joints. Equally important to the making of reliable solder joints are little-known facts concerning the forming and cutting of component leads before they are soldered onto the circuit board. After thoroughly cleaning the surface of the board and the leads of the component, the correct location on the board must be found and the component aligned with the holes before the leads are formed. The lead can be easily formed or bent with the aid of a pair of round nose pliers. Notice that the lead is bent beyond the 90 degrees necessary to enter a hole in the circuit board. This allows the lead to be bent back to the 90-degree angle and produces a sharp, clean bend that is well within recommended tolerances. The round nose plier is the recommended tool for forming wire leads. The circular jaws are tapered to accommodate wire of various diameters. The taper makes it possible to vary the distance of the wire from the front of the jaws to find a jaw diameter equal to the diameter of the selected wire. This relationship of plier jaw diameter to component lead diameter is important because of the internal stress caused by bends smaller than the wire's own diameter. A wire's own diameter is therefore the smallest bend diameter allowed for a component lead. To reduce internal stress damage to the component during the forming operation, always bend the lead from the side of the plier opposite the component. One last thing to remember about forming. Because of mechanical and heat requirements, the smallest distance allowed between a component and the bend of the lead is 1/16 of an inch. The leads are wiped again to remove any oils transferred from the fingers. A non-metallic spudging tool used for probing, forming, and bending wire leads is employed here to make half clinches on the component leads. The half clinches will hold the component to the board during the soldering operation. The leads are cut before the joints are soldered to reduce possible shock damage to the joint. Here's why. If conventional compression-type cutters are used to cut the leads, the 5 to 10 pounds of pressure exerted on the grips is amplified and dissipated by the jaws. This energy is used to force the wedge-shaped cutting edges into the metal of the wire. By using the law of conservation of energy and analyzing this action, we find that part of the energy created by the 5 to 10 pounds of pressure on the grips is dissipated into the cutting edges, making them dull over a period of time. Part of the energy is dissipated into the component or joint, resulting in possible internal or mechanical damage. And part of the energy is dissipated into the end of the wire, making it a projectile that can fly across the workspace. The recommended cutter for electronic work is the shear type cutter. Using about half the pressure on the grips needed by compression-type cutters and employing a different design, the cutting edges tend to shear the metal with most of the energy directed away from the component. Again, using the law of conservation of energy to analyze the action, we find that part of the energy is dissipated into the cutting edges and in time will dull them. A minimum amount of the energy is dissipated into the component or joint because of the shearing action of the cutting edge. This type of cut has a significantly lower damage potential. A larger part of the energy is dissipated into the wire end, making it a projectile capable of flying across the workspace. As with all the other elements of soldering for electronics, the recommended procedures for forming and cutting are essential for high reliability soldering.